Okay, in this video, we're discussing chapter 3, sections 3.4 and 3.5, right? And we're going to talk about energy in these chapters, in these sections, excuse me. So, energy is basically the ability to do work, all right? That's what the best definition for energy is, all right? Energy can make an object move, energy can make things stop, and so that ability to do work is defined as energy. Now, energy takes the forms of, excuse me, kinetic energy, which is energy of motion, and so anything in movement, all right? So whether the water falling down the waterfall, that water flowing over this dam, walking, moving, swimming, all of those are energy of movement. Heat also is a type of energy of movement. um, so anytime work is being done, so to speak, then that is involves movement of particles. So that's energy of movement, all right? Now, potential energy is stored energy. So it's energy that can be used for when is needed, all right? So energy in food, that's stored energy, all right? During the digestive process, that would be kinetic energy, energy of movement, all right? So water at the top of the dam would be potential energy. Compressed springs, or energy stored within the bonds of molecules, compounds, those would be as well potential energy. So there are just two main types of energy. If it is not potential, it's going to be kinetic. That means it's in motion, all right? Whether it's a heat motion or an electrical motion, it's a type of motion, okay? All right, so if you have like a stone at the top of a mountain, that is potential energy. As it starts rolling down the mountain, then all of its potential energy is being converted into kinetic energy or energy of movement. So identify each of the energies in each example as potential or kinetic. Rollerblading, that would be kinetic. Peanut butter jelly sandwich would be potential. Mowing the lawn, kinetic. Gasoline in the gas tank would be potential. Heat is also an energy of movement. So the faster these particles are moving, greater heat or thermal energy in that substance. So as you are providing heat to an ice cube, that means the particles within the cube are going to be moving very rapidly, which is why the cube starts breaking down, which is what we call as melting, because now the particles are now becoming water the liquid water molecules. They're still H2O. Chemical composition doesn't change, all right? So eventually from a solid state, it becomes into a liquid state as the particles get more movement and they start moving away a little bit from each other. Now, the units of energy are calories and joules. Joule is the SI unit, all right? Calorie, kilocalorie is still considered part of the metric system. However, the SI unit is joules and kilojoules, which is the bigger unit, all right? So 1000 joules make up the kilojoule, and then 1000 calories make up the kilocalorie. The conversion between cals and joules is 4.184. 1 cal is 4.184 joules. This is exact, all right? So this is another one of those conversions that is defined as being exact, just like 1 inch is equal to 2.54 was centimeters was defined as being exact, all right? So this is exact, this is exact, this is exact, and this is exact. Now this can be used, this conversion factor can be used to convert between cals and joules. All right, so this is some of the energy comparisons. And as you can see, energy from the sun is really high in terms of joules, okay? And then you have different energy from one serving of pasta, donut, energy for sleeping, etc. Okay, so it's kind of like an FYI if you want to look at it and check out all the energy consumptions for different things. Okay. All right, how many calories are obtained from a pat of butter if it provides 150 joules of energy? So the conversion factor is 4.184 joules to a calorie. So you have to take 150 and divide it by 4.184. So the setup is 1 cal by 4.184. So the joules will cancel. You're dividing the 150 by 4.184 and 2 sig figs. And so it's 36 cals. Okay, so that's answer C. So 1 hour of swimming uses up 2100 kilojoules of energy. So that's a good workout. Nutritionists are able to determine the calories in food by using an instrument called the calorimeter, right? So you have a container which is filled with oxygen. It's within a closed system, and you need oxygen for burning. Without oxygen nothing can burn. So the food is ignited or burned in the presence of that oxygen within that chamber, and then the heat from the chamber goes into the adjacent compartment which is filled with water. All right, so all of the heat lost from that burning of that food goes to the water, and so then you're using an indirect method to calculate the heat content of that food. All right, so here you have a nice picture showing that you're burning the food, and it's an enclosed chamber, and so is the water surrounding it. They're all in closed up chambers so that no heat is lost to the surroundings. And everything is conserved within the closed chamber. So then after you light that up, and as that heat is going out, it's flowing out, you have the stirring bar to stir to make sure that the heat is being evenly distributed throughout the water. And what will happen is that heat will be registered as a temperature change. So initially the temperature would be at room temperature, and then as that food is getting burned, as more heat is being produced, there will be a change in temperature. All right, and then this change in temperature is then used to determine that energy value for the food. Okay, so the food labels in the US have two units. One is in kilojoules and the other one is in kcals. So the big cal with a capital C is the food calorie. So the food calories are nothing but kilocalories, right? In other countries they use kilojoules because that's the SI unit, but in the US they use both. So there's a dual system for labeling the calories in the food packages. So the caloric or energy value of 1 gram of food is given in kilojoules or kilocalories. So all food is carbohydrate, fat, and protein. Therefore, these are the kilocal per gram values or kilojoules per gram values. And it's 494. Carbs and proteins are the same. So they're both 4, fat is 9. Carbs and proteins in kilojoules are 17 and the fat is 38. Okay, now here are some energy values for some of commonly consumed foods, and what is interesting here is that it's probably better to eat an apple rather than a banana. The banana seems to have the same kcal as a piece of chicken, but a very small piece of chicken, only 3 ounces. And However, the chicken does have more protein, whereas the banana has a lot more carbohydrate in it. Okay. All right. So continuing on, when we do these calculations to determine how much energy that we can obtain from sample of food, make sure that again follow the same steps. What are the given quantities? What is needed? Use whatever you have in terms of the conversion factors. Write them down. And then make sure that you're rounding the answer properly. Usually it's rounded to the tens place. This is important because then I've had questions in the past where people are confused about the sig figs. So all kcals or kilojoules calculated for the nutritional content of food is always rounded to the tens place. So remember that. And then once you determine the energy from each specific component, like the carbohydrates, proteins, and fat, then you can determine the total energy of that food sample. Okay. All right. A cup of whole milk contains 13 grams of carbs, 9 of fat, and 9 of protein. How many kcals does a cup of whole milk contain? So 13 times 4, 9 times 9, and then 9 times 4, and then you add them all up together. Okay. So 13 grams of carb times 4 kcal per gram, so that's 50 kcal. 9 grams fat times 9 kcal per gram, and that's 80 kcal. And 9 protein times 4 kcal per gram, and that's 40 kcal. And now you add them all up together, and remember the answer has to be to the tens place. Okay, so that's why you don't have a digit here in the ones place. It's rounded to the tens place, so it's 170 cals. All right, so this is like a chemistry linked to health, showing the number of kcals or kilojoules needed in the daily diet of adults depending on their gender, age, and their activity. Okay. So generally it's kind of calories in, calories out. You must consume less, and your output of cals should be more in order to lose weight. Right, so the problems for this section that is recommended is 3.23 to 3.26, and then 3.27 through 3.34. All right. And that's the end of this section, these two sections for this video.